The topic for Lesson 1-4 is angle measure. You'll learn to measure and classify angles, identify and use congruent angles, and the bisector of an angle. How big is a degree? One of the first references to the measure now known as a degree came from astronomer Claudius Ptolemy. He based his observations of the solar system on a unit that resulted from dividing the circumference or distance around a circle into 360 parts. This later became known as a degree. In this lesson, you will learn how to measure angles in degrees. A ray is part of a line. It has one endpoint and extends indefinitely in one direction. Rays are named stating the endpoint first and then the other point on the ray. The figure at the right, ray EF, which can be symbolized as ray EF, this ray could be also named as ray EG, but not as ray FE because F is not the endpoint of the ray. Now, easy little memory peg. Rays are the things that come out from the sun. Put arrows on them, I guess. If you chose a point on a line, that point determines exactly two rays called opposite rays. Line M, shown below, is separated into two opposite rays, PQ and ray PR. Point P is the common endpoint of those rays. Ray PQ and ray PR are collinear rays. Opposite rays are also known as a straight angle. Its measure is 180 degrees. Unless otherwise specified, the term angle in this book means a non-straight angle. An angle is formed by two non-collinear rays that have a common endpoint. The rays are called sides of the angle. The common endpoint is the vertex. This restates the same thing. An angle is formed by two non-collinear rays that have a common endpoint. So in this we have the vertex is at angle A, and it's made up of ray AB is one side and ray AC is the other. And you could name this angle A, angle BAC, angle CAB, so that vertex needs to be in the middle if you use three letters, or if they number it, angle 4. An angle divides a plane into three distinct parts. Points A, D, and E lie on the angle. Points C and B lie on the interior or inside of the angle. Points F and G are on the exterior or outside of the angle. Name all the angles that have B as their vertex. Okay, so there's the vertex B. I'm going to use the numbers they gave me, so angle 5, angle 6, and angle 7 all have vertex B, and then they didn't label this guy, so I'm going to call that angle A, B, G. We could have also done angle GBA, but we can't just call it angle B because there are 4 angles with that same vertex. Name the sides of angle 5. Okay, angle 5 has that vertex at B. There are the sides. So we would call that ray BG and ray, we could either call it BE or we could call it BF. It doesn't matter. Write another name for angle 6. Okay, there it is. So we could call it angle E, vertex is at B, D, or it could be DBF, FBD, DBE. Okay, so you get the idea. Big idea, the vertex needs to be in the middle. To measure an angle, you can use a protractor. Angle PQR is 65 degrees, or we could say simply the measure of angle PQR equals 65. And you can see there's the 60, there's the 70, it's halfway in between. We also have these big numbers, 110 and 120, but this opens from 0, goes past 60 to 65. So it's an acute angle that also lets us know that it should be the smaller number. So the protractor has two scales running from 0 to 180 or 0 to 180, depending on which way your angle opens. You want to align the 0 on either side of the scale with the 1 of the angle when you go to measure. And then since ray QP is aligned with the 0 on the outer side, use the outer scale to find that ray QR intersects the scale at 65 degrees. And yes, we place the center point on the protractor on the vertex. And different protractors have different styles, so we'll have to look at what you have. A right angle measures 90 degrees, and we use this little box in the corner to simplify that it's a right angle. Acute angle measures less than 90 degrees, and an obtuse angle measures between 90 and 180. And usually when you write between a statements, you start from the smallest and go up. You go in an ascending order. That's a little odd. Here's a good quick tip. The corner of a piece of paper is a right angle. You could use the corner to determine an angle's measure is greater than 90 or less than 90. Measure angle TYV and classify it as right, acute, or obtuse. Okay, well, angle XYV is right because they put a box there. So we know that angle TUV must be right also because they make a straight angle together. Two rights don't make a wrong, but I guess one right and a straight line makes two rights. Measure angle WYT and classify it as right, acute, or obtuse. Well, just eyeballing it, WYT has got to be more than 90 because we already did TYV and that was 90. So we know it's got to be obtuse. And sure enough, if we lay a protractor on there, it's going to go from 0 past 90 to 130 degrees. Angle TYU must be acute because it's less than a 90. And when we measure it, it's in fact half of 90. It's 45 degrees. Angles that have the same measure are congruent angles. The arcs on the figure also indicate which angles are congruent. And sometimes we'll add little tick marks on the arcs as well. Or if you're going to mark more than one arc, like this other one that's a different size, you might put two arcs on it. A railroad crossing sign forms congruent angles. In the figure, angle WVX is congruent to angle ZVY. If the measure of angle WVX equals 7a plus 13 and the measure of angle ZVY equals 10a minus 20, find the actual measurements of angle WVX and angle ZVY. Congruent means the measures are the same, so we have a nice little equation we can solve. Subtract 7a from both sides of the equation. So now I'm going to have 13 equals 3a minus 20. And if we add 20 to both sides of the equation, we're going to have 33 equals 3a. Divide by 3, and we get 11 equals a. Oh, I circled it, but that's not my answer. Rats. Okay, we want the actual measures of the angles. So we need to substitute back in 7 times 11 plus 13. So 77 plus 13 would be 90. Oh, that's a right angle. Just to double check, I'm going to substitute into the other expression as well. So 10 times 11 minus 20. And wouldn't you know, 110 minus 20 is also 90. That's a nice little check step for us. So that's actually our final answer. They are both 90. A ray that divides an angle into two congruent angles is called an angle bisector. If ray PQ is the angle bisector of angle RPS, then point Q lies in the interior of angle RPS, and the angle RPQ is congruent to angle QPS. Angles are classified as acute, right, or obtuse according to their measure. An angle bisector is a ray that divides an angle into two congruent angles.